This is the homework solution for sequence 1.7, the MVP. This is for the honors class. So we have ready and find the missing value for each arithmetic or geometric sequence. Underline whether it is a constant difference or a constant ratio. State the values of the constant difference or ratio. Indicate if the sequence is arithmetic or geometric by circling the correct answer. Alright, so number one, we're giving the sequence 5, 10, 15, blank, 25, 30, and blank. Right? You want to test for both the common difference and the common ratio. How do we do that? Okay, we get the second term and minus it from the previous term. So 10 subtract 5, that gets you 5. 15 minus 10, that also gets you 5. Right? We're going to test for the common ratio. That is finding, right, so the previous term, 10, divide the term, 10 divided by its previous term, which is 5. That gets you 2. 15 divided by 10, that gets you 3 over 2. Do you see how there is a conflict here? Right? The fact that it's a conflict, you know that the common difference here is 5. So once you know that it's a common difference, it is automatically arithmetic, because arithmetic sequence is the only one that has a common difference. Then you plug it in. So 5, 10, 15, the next one is going to be 20, 25, 30, then the last one is 35. Okay, so this is the process in which how you figure out if it's a common difference or common ratio. You have to test both of them. Okay, the next one, I'm also going to walk through this one as well. Here, the only terms I can use is 10 and 20, right? So 10 subtract 20, that gets you negative 10. So what I did is I decided to write the first couple of terms, right? 20, 10, 0, negative 10, negative 20. Does that match up? Nope. Test for the common ratio. 10 divided by 20 is equal to 2. Now I test out that common ratio. So it is, this is really 1/2, I'm sorry. This is really 1/2, right? So half of 20 is 10. Half of 10 is 5, 2.5, 1.5. Yep, that is correct. The common ratio for this one is 1 over 2, which is 1/2. Hence, it is geometric. 10, 20, 10, 5, 2.5, 1.25. Okay? All right. The fact that I show you in detail already how to do it, I'm just going to go over the answers now. Okay? Number 3, it is a common difference. The common difference here is 3. All right? Plug it into the sequence. It's 2, 5, 8, 11 is the missing term, and 15 is the last missing term here. Next one, 30, 24, you see it's going down. I test both the common difference and the common ratio. The common difference is correct. It should be negative 6. Okay? Hence, it's arithmetic. The missing terms is 18 is the middle value there. It's going down as well. The go. Determine whether the given information represents an arithmetic or geometric sequence. Then write the recursive and the explicit equation for each. Here we have 2, 4, 6, 8. I realized it's a common difference because, again, you can just use this test, right? The test for the common difference or the common ratio here. Okay? I saw that the common difference is 2 because 2 plus 2 is 4, plus 2 is 6, plus 2 is 8. Hence, it's arithmetic. Plug it into my original equation. 2 was my first term. That's why 2 plus function of n minus 1. The implicit is function of n is equal to the first value, f of n, which is 2, plus f parentheses n minus 1 times the common difference, which is 2. Or you could write it into y equals mx plus b, which is y equals to 2x plus 0. 2 represents the common difference, or the rate, and 0 is because the 0th term is 0. Because you go backwards here, it should be 0. Okay. Next, 2, 4, 8, 16. Do you see how it goes up to 16? All right. Here I'm multiplying by 2. The fact that I'm multiplying by 2, I know it's geometric. All right. Plugging the function of n is equal to r times function of n minus 1. The r here is the common ratio. Plug in 2. The implicit here, same thing. Plug in 2 here for the r value, and this is f of n, or function, the first term, which is 2 in the sequence. That's why it's 2 times 2 to the power of n minus 1. We have 7 here. We have a chart format. Again, figure out your common difference. The common difference from 3, 7, 11, and 15, it is positive 4. It is going up arithmetically because it's adding 4 to each time to get the number of dots. So The recursive is 4 plus the previous term. The explicit is your first term is 3, right? Your common difference here is 4. If you want to put that in y equals mx plus b, it's 4x plus -1. How do I get the -1? -1 is referred to the zero day here. So you would have to go back, subtract 4 from 3. That is how you got -1. Okay. 8, 5, 8, 1.8, 20.48. Right. Again, you just do division. Okay, I did 8 divided by 5, I got 1.6. If you do 12.8 divided by 8, you get 1.6. 20.48 divided by 12.8, it's 1.6. I saw that the common ratio here is 1.6, hence it's geometric. The recursive, again, 1.6 is the r, times that by the previous term. The explicit, the first term, which is 5, times the common ratio, which is 1.6 to the power of n minus 1. Next, Michelle likes chocolate but causes acne. She chooses to limit herself to 3 chocolate bars every 5 days so she can eat part of a bar each day. So the common difference is 3. The reason I know it's 3 is because she's eating 3 each day, right? Every day, right? And it's always 3. It doesn't increase, okay? It's 3 every single day. So it's a constant difference of 3. Hence, it's arithmetic. So the recursive, again, the common difference plus the previous term, so it's 3 plus the previous term. The implicit is always your first term, which is on her first day, she's eating 3 chocolates, plus f of parentheses n minus 1 times the common difference, which is 3. In y equals mx plus b, y is equal to 3 because 3 is the slope, right? The rate or the common difference, plus 0. The reason it's 0 because on the 0th day, she ate 0 chocolates. 10. Scott decided to add running to his exercise routine and runs a total of 1 mile his first week. He plans to double the number of miles he runs each week, right? Look at the keyword here. Double the number of miles, right? That is the key word. This indicates that it is changing, it is doubling, right? It is, in the process, it's geometric because it's being multiplied, right? Double means 2 times that. Right, so it's a multiplication, so it's 2 times that. We know that is geometric. Put that into the recursive formula. It is 2 times the previous term. The explicit form, the first term, right? It's 1 mile in the first week, so it's 1 times r, which is 2 to the power of n minus 1. 11. Vanessa has $60 to spend on a ride at the state fair. Each ride costs us $4. The common difference here is -4. The reason why it's -4 and not +4 is because she's losing money, so that's why it's -4. It's arithmetic because she's losing $4 for every single ride she's going on. The function here in recursive form is -4 plus the previous term. The explicit here is the first term is 60, right? Because that's what she starts off with, right? Plus No. This is the first term. So the first term means she goes on 1 ride. So it should be 56. Yes. Right. Plus, right? Because the first term represents 1 ride already. So that's why it's 56, not 60. 60 was when she goes on 0 rides. So in f of n, that is equal to 56 plus f parentheses n minus 1 times -4. Or if you plug into y equals mx plus b, it makes a little bit more sense in y equals mx plus b because -4 means, right, that's her slope or the rate, because each ride costs us $4, right? Cost, which is -4. And the y-intercept is $60 because, again, 0 ride where she starts off with is $60. That's why it's 60 here. All right, 12. Cami invests $6,000 in an account. It earns 10% interest each year. Okay, very difficult to do without, because the percent interest, right? Always make sure you put it in a table of values to just get a better visualization. Again, once I have the table of values, do it exactly like right here, okay? In terms of applying the test for the common ratio and the common difference. All right, the chart is very useful. So I did 6,600 subtract 600, right? It doesn't make sense because it doesn't go up, right? And also it's a percentage, so I know it's geometric, so I do the division. So 6,600 divided by 6,000, or 7,260 divided by 6,600. You should get 1.1 after you do that division, right? It's geometric, so if you plug it into the recursive, it's 1.1 times the previous function, or in the explicit form, you start off with 6,000 because that is your first year, okay? Right? Okay, and 1.1 to the power of n minus 1. Good. The reason why it's 1.1 is because you're gaining that interest, right? That's why it's 0.1. Okay. If you multiply it by 0.10, you're losing money. Does that make sense? You have to multiply by a value greater than 1 for it to be increasing. All right. Next, for the following problems, 2 points and slopes are given. Plot and label the 2 points on the graph. Draw the line segment between them. Then sketch on the graph how you count the slope on the line by moving up or down, then sideways from one point to the other. I'm going to show 13. Okay. I'm going to show 13 so we can all see it. Give me a second here. I'm grabbing paint right now. All right. So here we go. So, alright, so they want to, let's do A. So, 2, positive 2, negative 1 is right here. This is going to be A. Okay, then let's do the next one. B, 4, comma 2, so 4, comma 2, right? And we know that that is B. Good. Then you want to apply the slope, okay? Right, let's count that. Alright, so this is what you're doing when you're going up or down, right? Then the bottom is sideways, okay? So up to 1, 2, 3. So that's our 3. Okay, that's that 3. Alright, then the bottom, it's 2, right? 1, 2. Does that make sense? Okay, alright. Good? Okay. So I could even do that to the next term. So the next one should look like this. Okay. I could go forward or I can go backwards. I'm going to go backwards here, right? So I go down 3. 1, 2, 3. Then across 2. So 1, 2. That should be where the new point is. Right? Match up the line. Perfect. Oop, not that perfect. Should look like that. Yep, good. Right, there you go. Okay. Right, that is how 13 looks like. I also did it for 14 right here, but I'm not going to show it in detail. Again, red here is H, and this is 2, 5. The K is right there. Right, connected with the red line. Here, I didn't want to go up, so I went, I can go up, but I decided to go backwards. So I went down 1, across 1. Right, do you see how, if you go forward, up 1, across 1, up 1, across 1. When you go backwards, you just have to do the slope backwards, okay? Same thing for 15. Plot the point. P is in the middle at 0, 0. Q is up there at 3, 6. Apply the slope 2 over 1. You're going up 2, across 1, up 2, across 1, up 2, across 1. Or do the opposite, right? Down 2, across 1, down 2, across 1. Do you see? It reaches each point, okay? Next one. For the following problem, 2 points are given. Plot and label these points on the graph, then count the slope. Alright, I'm going to do the first one for you here. Alright, so let's just make sure we get rid of our previous problem here. Alright, so let's do this. Let's plot the first one. 3, 0. Right? So negative 3, 0. Okay. 3, negative 3, 0. And we call that C. Okay. 0, 6. So let's do that. 0, 1, 2, 3, 4, 5. Good. Then we want to count the slope. Okay. You want to do the up and down first, right? The y first. 1, 2, 3, 4, 5. Okay, so it's 5 over. Then you want to do the, I think you could see pink. 1, 2, 3, 3. That's positive 3 because you're going to the right. That's 3. Right, there you go. So that is your slope. Right, I'm going to grab it there. Okay, there you go. Same thing for 17 here. I did that. The slope here was -5 over 2 because you're going down -5, right? Because down is negative on the y-axis. Then you're going to the right, which is 2. Okay, good. Here I labeled the points again, right? S at 0, 3. W is 1, 6, right? You want to do your y first, which is up 3, then across 1. That is why it's 3 over 1. There you go. Those are all your homework solutions.